In the last couple of videos, we created array lists but didn't do much else with them. Now it's time to do something with them. First of all, you can retrieve an element in an array list by its index, much like the way we reference an array element by its position in square brackets. For an array list, we use the get method instead of square brackets. I'll show an example of using the get method to print out the third element in my list. Print out the value returned from groceries.get with 2 as the argument. Like arrays, array lists start with a 0 index position, so the third element is at index 2. This code simply prints out third item equals milk. Next, let's talk about searching for an item in the list. The array list provides several methods to help us do this. First, there is the contains method that returns a boolean, true meaning it found a match. If groceries dot contains the string literal mustard, print list contains mustard. And if I run that, I get the message list contains mustard displayed. This method will work for many of Java's built-in classes like string because it ultimately calls the class's overridden equals method. We'll look at this more for our own classes in later lectures. We can also use the index of method and the last index of method. If either method finds the element, it returns the actual index position instead of just returning true or false, and they return -1 if the element was not found. Array lists can have duplicate elements. Let's see how that works. I'll add yogurt using groceries.add. Print the value returned from groceries.index of for yogurt. And the same for groceries.lastIndex of. And running this code, you can see that the index of method found the first instance of yogurt at index 4, and the last index of method found the other yogurt element, the one we just added, at index 8. In addition to finding elements, we have several methods we can use to remove elements from a list. We can remove by index if we know it, or we can remove by the element's value itself. Print out groceries. Remove element 2 from groceries with a call to groceries.remove. Print out groceries again. This time pass the string literal yogurt as the argument to groceries.remove. Print out groceries for a third time. First, I'm printing the full list out before I remove anything, then I remove the second element in the list by passing the int value 1 to the remove method. I then print the list again. I then remove yogurt from the list, passing the string value this time, and print the list again. Let's see what happens now. You can see that bananas, the second element, was removed. In addition, yogurt was removed, but only the first element. So the remove method only removes a single element from a list. There are options to remove more than one element at a time. Groceries.remove all, passing a list containing apples and eggs. And I'll print out groceries again. So again in this code, I'm using the static method list.of to create a temporary list from a variable arguments list of elements. These are the elements I want removed, so if I run this code now, my list no longer contains apples or eggs, both were removed. Another method that might remove elements is called retain all. This method's functionality is opposite to that of the remove all method, but since it potentially removes elements from a list, let's look at it next. I'll add a call to this method with a set of items. Groceries.retain all, passing this list of 4 elements. Print out groceries again. I'm using list.of again, passing 4 grocery items. This list gets passed to the retain all method called on my groceries list, and this method removes every item in the grocery list which isn't one of the items passed in the argument. After executing this method, my list should only contain 3 items: milk, mustard, and cheese. Before this call, our list didn't include apples, so that element is just ignored here. As you can see, we are left with just milk, mustard, and cheese. Finally, I can remove all the elements from a list with the clear method. Groceries.clear. I'll print groceries. Print out groceries.isEmpty. This code clears all elements in the list, and I'll print that out to confirm it. And while I'm at it, I call another method on list called isEmpty, which returns true if the list has no elements in it. Running this code, you can see an empty set of square brackets confirming the list is now empty and is empty equals true. I'll add some elements back to this empty grocery list using the add all method. I'll call it twice and pass it lists from 2 factory methods, the one on list we've used several times, but also another that's on the arrays helper class. groceries.addAll passing a list of 4 items, and same as above, but use arrays.asList this time. By now the first statement should be starting to look familiar. I'm using the static method list.of with a variable list of strings, then passing that result to the first call to the addAll method on my groceries array list. Like list.of, arrays.asList takes a variable argument list of elements and produces a list, and I can pass that list to my second call to the groceries.addAll method. After executing these methods, I'll have 8 elements in my list. Now that I have populated the array list with data again, let's see how to sort the elements. ArrayList has a sort method, so I'll just call it on groceries. Print out groceries, groceries.sort, passing comparator.naturalOrder. Print out groceries again. I print the grocery list before I sort it, then I actually sort the list. This method has one argument, which is a type called comparator. This is a special type that allows instances to be compared to one another. I'm going to be talking a lot more about comparators when I talk about interfaces. For now, to be able to use the sort method, a comparator is needed, and Java provides the one I need with a static factory method on the comparator type called naturalOrder. I call it and pass the result directly as an argument to the sort method. This object allows array lists with types that have a natural order to be sorted. Strings will be ordered alphabetically from A to Z, for example, and numbers will be ordered from smallest to largest. Let's review the output. You can see the grocery list gets sorted correctly. You can also call the reverse order static method on the comparator type to sort in reverse. Groceries.sort, but using comparator.reverseOrder this time. Print groceries. Let's check our results. And the groceries are now printed in reverse alphabetical order. Okay, so we've looked at 2 ways to transform arrays or variable arguments into list. Now let's go the other way, getting a list from an array with a different method on ArrayList. This is an overloaded method appropriately called toArray. For the sake of time, I'll show you the most commonly used version, which takes a typed array as an argument. This method will return an array the same size as the array we passed to it and of the same type. var grocery array equals groceries.toArray, passing a new string array of size groceries.size. I'll call arrays.toString on grocery array. Here I'm passing a new string array to the toArray method, which is initialized to the type and size I want the returned array to be. In this case, I want an array that has the same size and type as my list. As a result, this method returns an array of string. There may be times you might want to pass your data as an array to methods that accept arrays rather than lists, as an example. Here I simply pass the array to the arrays.toString method and print the array out, which we know takes an array as an argument. Okay, so that was a pretty fast review of a lot of methods on list, which are also implemented on the ArrayList class. In the next video, we'll review what we've learned so far while comparing the array and the ArrayList side by side.